Flame straightening is a method that has been widely used since the 1930s, and now more than ever before. The simplicity of the technique and equipment, combined with the ability to work with most objects, regardless of their size and weight, has made flame straightening a cost-effective method. Its advantage lies in the enormous forces which can be brought to play through the use of a heating flame. Forces we can use to straighten or stretch objects in metal. In order to work with flame straightening in an efficient and controlled manner, we must first have a thorough understanding of the principles of the method and how it actually works. First, let's see how a metal rod behaves when heated. The portion of the rod we heat will expand and therefore increase in total length. As the material cools, it will contract, returning the metal rod to its original length. Notice, we have not altered the rod's shape. But suppose we place a metal rod in a fixture strong enough to prevent any increase in length. What happens then? The heated material wants to expand lengthwise, but the fixture we put the rod in hinders this. The material is therefore forced to expand in a different direction, in this case, away from the rod. It now undergoes what we call a plastic deformation. This deformation is permanent and cannot be reversed. As the material cools, it contracts as before, this time resulting in a shorter rod. Both expansion and contraction are strong forces, and thus the key elements in the flame straightening method. Let's study the following theoretical example in order to show how powerful contraction forces are. We've welded a 1 centimeter rod vertically to a strong beam. We now heat the rod so that it expands lengthwise. Before it cools, we'll attach a 2-ton weight to it. As the rod cools, we see that the contraction forces lift the weight from the floor. We now begin to understand what enormous forces there are to work with, forces we'll learn to use and which are central to the flame straightening method. Let's recap. Metal, when heated, will expand. As it cools, it will return to its original shape. If we block it, the expansion will cause a plastic deformation in the heated area. Once cooled, the material will have shrunk. Contraction forces are very powerful, and we can use them to our advantage. Let's use our knowledge about contraction forces to straighten this beam. Remember that flame straightening is always based on contracting a specific area. Therefore, always begin flame straightening work by analyzing the workpiece for the longest section. This is where we need to shorten in order to straighten our beam. But before we begin heating, we must ensure that we create a plastic deformation where we heat. That is to say, we must prevent the material from expanding, just as we did with the metal rod in our example. We say that we block the material from moving. Blocking can be performed principally in 2 ways. One way is to prevent thermal expansion, by means of a mechanical restriction. Each piece needs its own type of blocking, which in turn will determine the design. A second method to force a plastic deformation is to use the material's own weight as a resistance, a method often used on beams and profiles. For flame straightening in beams and profiles, heating in the shapes of wedges is often used. We understand better if we take away a bit of the material and put a hinge here. It will give this result. This is called a knee effect. What's interesting are the inward forces which try to bend the knee. This means that a free-hanging beam has forces within it in this direction, which can be used in straightening, thanks to gravity and the knee effect. These forces will prevent the heated area from expanding sideways. Since this beam has enough weight of its own, we can use the knee effect to block heat expansion. What we will really do is use a number of heat wedges. How many we use will depend upon the length and magnitude of the deformation. Since the heated material is now hindered from expanding sideways, a plastic deformation occurs. As the material cools, the powerful forces of contraction will begin their work. The top side of the beam will contract the most, thus straightening the beam. When working in practice, it's important to do things step by step. By using a number of heat wedges and by measuring the results after cooling, we can control the work. This applies to all flame straightening. Here, we'll use the flame straightening method to bend a U profile by shortening the top side of it. We've placed the U profile on two supports, thus blocking the expansion by using its own weight as resistance. Contraction forces will do the job for us. Welded sheets of steel are often subject to some form of deformation. This stainless steel sheet welded onto a frame is no longer flat. Applying heat in selected spots is a useful method in this case. Always work from the outside to the middle. As the material cools, the same forces mentioned earlier will stretch the steel sheet. But why must we use a hammer? Thin sheet metal has the characteristic that when heated, it will push up like this. In order to achieve the necessary deformation, we need to use a hammer. The force of the hammer causes the area to deform, and we achieve a plastic deformation. As the material cools, contraction forces pull the heated area from all directions, and the material straightens. This method is often used in the manufacture of sheet metal covered constructions, such as these train coaches. Not only does the method improve the appearance, but it also prevents noise from excess movement. Therefore, all the sheeting is stretched using the flame straightening method. It's also possible to prevent sheet metal from raising by placing a vacuum plate on the side opposite the heated area. The vacuum plate helps the thin sheeting to resist the expansion forces and thus achieve an immediate plastic deformation. This can also be achieved using a perforated template and a counterplate, which mechanically forces the sheeting to remain in place and thus force a plastic deformation in the heated area. In the shipbuilding industry, where thick plates of steel need to be welded, heat deformation of the steel will often occur. HDW in Kiel is one of the most modern shipyards in the world, and flame straightening is an important tool for minimizing production time and costs. Practically all welded surfaces are flame straightened. Used properly, flame straightening provides a major benefit to production. That, of course, means the right equipment in the hands of qualified personnel. Even though techniques and production methods are continuously developing, flame straightening will continue to be one of the shipbuilders' most cost-effective methods for straightening steel plate. We've constructed a section similar to a ship's deck to demonstrate how effective flame straightening is. Remember, the basic rule of flame straightening is to do things step by step. So we start by applying a number of heat bands and await the result. After a few cycles of heating and cooling, the steel has straightened itself. Applying heat in bands is also beneficial when straightening welded beams, which tend to have hanging ears after welding. A couple of jacks are used to block the material. Three bands in the middle of the beam, using a double nozzle, is enough to correct the problem. A third method for applying heat is used in straightening pipes. This T-pipe was deformed at the time of welding. Flame straightening can be used to correct the problem. The heat is applied in spots and ovals to straighten the pipe. This is one way to apply heat when it comes to pipes. Let's recap. Depending on the object, there are four principal methods to apply heat. As wedges, often used in various forms of beams. As spots, often used to stretch thin sheets of steel. In bands, often used for thick plates, such as in shipbuilding. As ovals, used among other things for various kinds of pipes. Naturally, various methods can be combined depending upon the object and desired result. The gases needed for flame straightening are oxygen and a fuel gas. The ability of a fuel gas to achieve rapid, focused heating necessary for flame straightening is usually indicated by its flame temperature and intensity. This diagram shows the temperature of the flame. As we see, acetylene yields the highest flame temperature. Even in this diagram, for flame intensity, acetylene reports the highest values. Acetylene is therefore the gas of choice in flame straightening. Most common materials can be flame straightened, but it's important to remember that different materials require different techniques. Various materials expand quite differently when heated, as seen by the meters indicating the amount of expansion in the samples. Heat transfer is also different from material to material. Therefore, it's important to consider when working with various dimensions, which equipment is best suited to the material and type of object. Which method is best for heating? How shall we block heat expansion? These questions are answered in AUGA's handbooks, which can give practical tips in the choice of equipment, methods, and settings. Flame straightening is extremely cost-effective. in that only one person is needed for most of the work. Further, no heavy and expensive equipment are needed. Ver of Germany manufactures overhead bridge cranes spanning 35 meters with capacities up to 150 tons. These beams require a slight bend. Flame straightening will do the job. Another example of how flame straightening can be used in manufacturing is in the construction of this steel bridge. The bridge was curved by means of flame straightening. Two pre-constructed straight bridge girders were brought to a central height of 4.12 meters. This 45-meter chimney was delivered in two parts. Welding together the two parts at a height of 25 meters caused distortions, which resulted in a leaning tower. By flame straightening, the overextended side of the chimney was shrunken and the overhang of 4.5 centimeters corrected. We visited HDW in Kiel earlier. There, a flame straightening method is also used for forming heavy plates three-dimensionally. HDW has a craftsmanship and professional know-how developed from decades of work. The massive weight of vessel plating is used to block heat expansion, as they use flame straightening to bend the steel in different directions. This is how the bow of a ship can be formed, for example. Lavatec manufactures large washing machines in Heilbronn, Germany. In order to avoid vibrations in the sides of the washing drum, the sheeting is stretched on all sides by flame straightening. A number of heat spots are applied symmetrically. When the spots cool, the material stretches, and the drum will be vibration-free during rotation. Ehlen is a corporation in southern Austria which manufactures heavy constructions for the power industry. The extensive welding during the construction of this transformer core caused distortions. Flame straightening is an effective method to correct the distorted parts. For a company that works almost exclusively with extremely large constructions, flame straightening is an important part of production.